Hi, in this lecture, I'm going to talk about algorithms and high-level languages. The single most important topic that you will learn is problem solving in this class. Problem solving uses algorithm. What is an algorithm? An algorithm is a step-by-step list of instructions that, if followed exactly, will solve the problem under consideration. Algorithm is like a cooking recipe. Algorithm is like a instruction. If you follow instruction correctly, you should be able to, for example, doing the IKEA furniture. If you follow instruction exactly, you should be able to assemble the product. Our goal is to take a problem and develop an algorithm that can serve as a general solution. For example, how to open a door. You place your hand on the doorknob, turn the doorknob clockwise, and push the door. Typically, you will push the door to open the door, but um, these are the steps you would use to open the door, right? So these are like an algorithm. Computer programming is all about solving problems. It's all about creating algorithms. You first need to know how to do something by hand or manually, which is algorithm, before you can write a program. A lot of times, students will try to write a program before they understand what the problem does. So before you actually write a program, the first thing you need to know is understand the task that the program is to be performed. What does the program do? And then determine the step that must be taken to perform the task. And that is creating algorithm, and then you write the code and test it thoroughly. When writing an algorithm, you need to ask yourself some question. What information do I need before I start? These are the input. What do I do with this information? This is a process. And what will I produce with this information? This is the output. This is known as input, process, output, or IPO program. So a lot of time, we will write program that prompt user for input. You do something with the input data, and then you display the output. For example, um, if you want to write a program to um, provide like a change, given 79 cents, how much change you would give to user. 79 cents, typically you would give 3 quarters and 4 penny. How do you do that? The process. And 3 quarter, 4 pennies, these are the output. But um, how do you do all this? And we will learn these process in this class. Um, we write algorithm and then we program that. Programming language, there's a lot of programming language. The most difficult one I can tell you is the machine language. In the machine language, it uses ones and zero, and that is something you don't want to program because you will never remember how to do it. And what do we use? Well, we prefer to use a more human-friendly or user-friendly high-level language. The high-level language cannot be directly executed by the computer. It has to translate it first, and there are two approaches. You can compile or you can interpret. The program or the source code in the compiled languages, the program or the source code are translated into executable by compiler. In the compiled languages, you are looking at like a C++ programming language. Um, this will produce an executable file when you compile the program into executable code. Think about like in a Windows.exe program. And this can be executed zero to many times. I mean, the file is there. It's just sitting there to be waiting to be executed. It's compiled once and execute many times. Once you compile, you do not need to compile again. So pictorially, this is what the compile language look like. Simplified form, of course. You take a program, you compile it, and you have an executable. The advantages: a compiled program typically run a lot faster. But you can only run on the machine that has the same instruction set. So if you compile on the window, then the program can only run on the window. If you compile on the Linux, then the program can only run on the Linux or a different version of a Linux. You can self-copy the executable without revealing the secrets of the code, although we can reverse engineering if possible. The other programming language is interpreted language. They are not compiled. They are translated during the runtime. Translate every time the program is executed, and they translate into bytecode, and the bytecode is interpreted by the language interpreter. Translate once, execute once. So every time you run that, you have to translate. So that's what it looks like. And the interpreter translate the program into bytecode, and the bytecode, the interpreter execute the bytecode. Advantage? Well, it's a platform independence. When you write a program, it can be run on many different platforms: Windows, Linux, even a Mac, and other platform. Dynamic typing. Some variable can refer to a string, then integer, then anything else, which you cannot do with the compiled language. Typically have a smaller executable size because your source code is the program that you're running. Of course, there's a disadvantage, portability. You cannot run the bytecode unless the machine has the interpreter installed. Speed-wise, interpreter language runs slower than the compiled language. Cannot sell a copy of program without reviewing the source code. That's not really much of an issue because a lot of programs are open source. People can see the code. But the advantage of the interpreter language outweighed the advantage of the compiled language. One of them is speed of the development. You can write code a lot faster with the interpreted language. And here's some comparison. Compiled languages, compile once, creating an executable, it runs fast. It can run on any machine having the same architecture and the same OS. Interpreted languages translate program line by line each time they are executed, much slower. It can only run on any machine having the interpreter installed. We will talk more about interpreted language when we talk about Python next.